All right. So we are doing 4.2, and I'm doing something that's not on camera. Not on camera, sorry. Operations with fractions. I know some of these things are easy, but if we don't at least take a moment to think about them, just check. How easy is this? Am I okay? Then we might be caught off guard when Timmy asks me a fraction problem and I'm not quite sure. That hesitation, that fear that I might have comes up, transfers to Timmy or his friend that's watching you, and it's over. You don't get it back. It takes a lot of work to change negativity, but it's very quick to create negativity. Very unfortunate. So for 4.2, we're doing plus, minus, and multiply. For 4.3, I leave division for a separate section because I just want to take a little more time. Because in division, the intuitive side fails more quickly than the other ones. So we'll do addition and subtraction first, and we'll do them together because we've seen in the past there really is no subtraction. It's really only addition. Subtraction is just a convenient concept, but it's no different really. Now we're not going to worry about that. We'll see them as, or pretend that they're different. What I do want to note, and we've seen it yesterday, but it wasn't maybe as explicit. If I have a fraction, let's say 2/3, 2/3. We looked at equivalent fractions by multiplying the same number on both sides. I get an equivalent fraction, and that number could be anything. Let's say it's a 4. Just to pick a nice number. And then I get 8/12. So the quantity that represents is exactly the same. What is the intuitive visual equivalent to this times 4 and times 4? What do I do visually to create this 8/12? And in a sense, create this multiplication on both sides. You remember yesterday? I know it was Thursday, you were thinking about Friday, now it is Friday, it's hard to focus. I did a sideways split into 4 in this case. So these were shaded. So now I get 1, 2, 3, 4, 5, 6, 7, 8 out of 12. So this multiplication on both sides, I had 2 shaded pieces, split it into 4 sideways, that's times 4. I had 3 pieces in my one whole, split it sideways into 4 pieces. I've multiplied to 3 times 4, 12 individual small little pieces. So it's good to keep in mind that this multiplication, creating an equivalent fraction, I can get by the sideways splitting up.
Like further subdivision. Yeah.
Further subdivision. I've done vertical for the original fraction. It's just my method. It doesn't have to be exactly like this. I've done vertical, so I can subdivide it horizontally to create this equivalent fraction. And the choice of how many lines I draw here, how many pieces I split it in, will correspond exactly to the common factor that I'm creating. Okay, so if I have, so should we write this down? The common factor can be seen as horizontal lines in the rectangular representation. So it's good to have a system for how we are doing this intuitive side. so that I'm going to use vertical lines for my original fraction, and I do have the option of playing with these horizontal lines, and it does something, but I do it visually. There's an equivalent property of fractions, and that property is the common factor. That creates an equivalent fraction. All right. So now, as an example, I have 2/3 plus 3/4. Now, if you just stick to the far left, the intuitive side, you make the 2/3 something like that, or something less perfect, and you want to combine that with another quantity, 3/4 of a whole. But now if your pieces aren't split very evenly, then it's hard to see. How do I merge those two? And little Timmy is going to feel, yes, I have a hole, because this feels like it's more than the missing part here. So I'm going to get 1 and a little something. He's also going to agree that I don't have enough for 2 holes. It just doesn't look right. So I'm going to get a little more. But what on earth is that? I can't trust my drawings, my rectangles, to say accurately what that little extra fraction is. I have no idea. Visually, no idea. I have to look at another way to work with fractions in order to get the answer correct with confidence every time. The problem really is because the 3 and the 4 are different. That's the problem. That's why it's hard to compare and combine them. But luckily, when we compared the two fractions, what did we do? We saw these in a way that had the same denominator, and then it's easy to compare. So simply rewrite them to a common denominator. Now it really doesn't matter which. It doesn't have to be the smallest common denominator. You just have to have one of them. So 2/3 was originally represented like this. 2/3. 3/4 was originally represented into 4ths here, and I have 3 of them. Thinking of this common factor, creating equivalent fractions with sideways lines, I can take this 4 and split the first one into 4 pieces. I can take the 3 and go to the other rectangle and split that into 3 sideways pieces. What have I really done? I've done, I'll write them here in a second. I've done, by doing that visually, intuitively, I have really multiplied by 4 on both sides to create the fraction 8/12, but I didn't have to do that because visually I see 8/12. Here, by doing this, intuitively, I am actually performing, or looking at the property where I multiply both sides by a 3 in this case, and I get 9/12. And by choosing the other denominator, I'm going to make sure that I get the same common denominator for the two equivalent fractions. So for this one I choose the 4, for this one I choose the 3. I just let them cross over. And it's always going to give me the same denominator. Not going to necessarily be the lowest one, but I really don't care. It doesn't really matter. I'm just looking at an intuitive approach. So then clearly, if I have 1, 2, 3, 4, 5, 6, 7, 8 pieces here and 9, how many will be in my answer? Well, Timmy was right in that, sorry, that's a little big. Timmy was right in that it fills 1 hole. It's definitely enough. So let me divide this into 12ths again. 3 vertically, 4 horizontal, and I have 12 little pieces making up my hole. And I'm going to have enough to probably fill some of another hole. So I'll just set it up. Oops, that should be fourths, like that. Now I have to figure out, okay, I have 8. 1, 2, 3, 4, 5, 6, 7, 8. This is now the intuitive side, right? And another 9. So tell me, we just count them off. 1, 2, 3, 4, 5, 6, 7, 8, 9. So clearly, the answer would be 1 and 5 12s. The only catch or trick or method involved here on the intuitive side, and really any side, is I need a common denominator to be able to compare them effectively. But he never has to do any of this. By doing the horizontal lines, he is doing this rewriting to a common denominator. So we would say, on the mathematical side, we could write it, and we do eventually, write it as, what is it, 2 over 3 plus 3 over 4. I see, okay, I need a common denominator. There is a choice. 12 is the convenient one that comes to mind first. So this will be times 4, so 8 over 12. I have to multiply both sides here by 3 to get the 12 in the bottom, so 9 over 12. So this will be 17 over 12, which I then convert, and this is the same. But on the intuitive side, you don't really come up with improper fractions. You're counting the number of holes and the little left over, so you'll get a mixed number instead. But they are equivalent. So that's my method for addition. And subtraction will work the same, but let's just practice one more for addition. What do I have here? Oh, I don't have any examples. Wow. Random example. I don't know. I don't want the fractions to be too bad. Let's go 2/5 plus a half. I have to, again, remember, this is what the theme is for this whole module. I have to be able to freely move between the left and right side of a concept as the need arises. I have to be aware of the left and the right. So I'm going to do my 2/5. 2/5. That's over there. And my 1/2. This is now the left intuitive side for little Timmy. And I have to be able to do that. I'm going to rewrite this, take this 2 and split it according to that number. Take this 5 and split it according to that number in the other one. Nice thing is that the pieces don't have to be perfectly equal in size. So then this says I have 1, 2, 3, 4 tenths. And I have 1, 2, 3, 4, 5 tenths, which we already know. They might look the same, but they're all, each one is splitting their whole rectangle into 10 equal pieces. So then I could say here, this is 4 over 10 plus 5 over 10. Now, I'm doing both. The more to the right side, you don't need a diagram. Little Timmy needs a diagram. So now I'm counting. In a whole, I need tenths here. Now you can go either way. Let's go the top one maybe. 5s, and then cut them in half to create tenths. I have 4. 1, 2, 3, 4. And another 5. 1, 2, 3, 4, 5. Not quite enough to fill the whole rectangle. So I get 9 over 10, which we can see here, 9 over 10. Now if I write this in a little more detail, we could also write, not for Jimmy, just for us, to get to this answer, it was over 10 is my answer. I'm gonna erase this in a second. It was 4 plus 5 that got me to my 9. Where does this 4 come from? Where does this 4 come from? It was this 2 times that 2. Because they're both 2, just keep track of them. Where does the 5 come from? It was the 1 times the 5. So my general rule here is if I have A plus B, A over B plus C over D, that'll be over A times D. Think of, 2 and 5. 2 times 5 is 10. And that's exactly what I did here. I made a common denominator of 10. These two get multiplied. B times D, sorry. B times D, 2 times 5. A times D plus, doesn't matter, C times B. But am I going to show little Timmy that and say, just use the formula? No, that does not create intuitive understanding or anything. It is a cold mathematical way of expressing the properties for how to, and the method for how to combine fractions. Yes, when the numbers get really ugly, I'm going to rely on this. But when the numbers are easy, I can be on the left and use the intuitive side to introduce the concept. And it's much more fun for kids anyway. Make little rectangles, maybe you have something more physical that they can manipulate. It's a lot more fun. That, to little kids, that is not fun in any way. And everyone already thinks math isn't fun, so we don't want to promote that. But that is what I would go to if I have an ugly fraction. What on earth do I do then? If I don't have a calculator. I use my property, my rule. Will get me to the answer. It's just not going to be very pretty. And these numbers won't be nice for rectangles. So when the numbers are ugly, I move over to the right because I understand in mathematical terms how to add fractions. Now the subtraction is exactly the same. Exactly the same. Let's take, let's take that one. 1/2 minus 2/5. That's exactly the same, except I'm taking away. So I have my first one, 1/2. So I split it like that. There's a half. And I have my 2/5. Let's not do that. I don't want to see it. I don't have it. I'm taking it away from this. But I'm taking away 2/5. Let's say here, take away 2/5. But how do I see 2/5 here? I need a common denominator. So again, I'm taking this 5, splitting it up sideways to create 5 tens. And this, should I do it? Yeah, okay, no, I guess I have to see it. It's not actually there, but I do have to visualize it, I suppose. This is what I'm trying to take away from this region. But I can't see it necessarily until I take this 2 and split it in 2 and see that that's actually the same as 4/10. So now I can go here and take away 4/10 from here. I have 1, 2, 3, 4, 5. I'm trying to take away 4. So how many will I have left? I only have left 1/10. Or 1/10. Does that make sense? Instead of adding and combining, I'm just taking away. But I have to figure out exactly what am I taking away. And the only way to do that is to have a common denominator. So I can rewrite this perhaps, 5 over 10, take away 4 over 10, which is then clearly going to give me just 1 over 10. So the idea is exactly the same. Just trying to figure out exactly what am I taking away and exactly how much do I have. I can't compare these with confidence. Common denominator, and it's extremely easy. So that's the only secret, that's the only key to this. And then of course the general rule would follow something very similar to that one over there. Though I have to know it, I'm not going to teach little Timmy this rule. It does not create anything positive for him in the beginning. There's a time to do that, and the time is when the numbers get ugly and I can't make rectangles anymore. Then it naturally crosses over, and he has a need. Like, I can't draw 23rds. It's too much. Can you give me something else? Okay, well, let's find a pattern here that actually works like this. So it'll be AD minus BC. But it has to happen more naturally. If you force a formula on them, it tells them, don't think about it, don't have any understanding, just apply the formula. But if I understand first, and then use a formula as the need arises, then it's much better. Same thing with the calculator. People run to the calculator too fast. And then they stop thinking, or they don't know how to do it anymore. The calculator is there when the numbers get ugly. Then I have a device to help me just do it a little bit faster. It doesn't mean I can't do it. It doesn't mean it thinks for me. It's just there when things get more complicated. Multiplication. Now, I guess it's just good news. We don't want to bore ourselves. Multiplication and division are actually pretty nice when you stick to the intuitive side on the left. It's very interesting how one can explain it. First thing is, what does something like 2/3 times 3 over 4 mean intuitively? What does that mean? How do you understand multiplication of fractions? Now, multiplication of integers or whole numbers, that's easier. Because if I take 2 times 5, I am doubling the 5 to create 10. It blows up the number. I'm going to get something bigger. But with fractions, it doesn't work like that. It's in some ways the opposite. How do I understand the concept of multiplication intuitively? Does anyone have any thoughts? It's a simple word that I replace that multiplication sign with that makes things, in my opinion, for me at least, much easier. But without that word, no idea. What is a little 2-letter word that I can replace that multiplication sign with? See, we need to think about these things. Because if I use the right word, it unlocks the intuitive understanding. What is the word? Does anyone have a guess? I told you it's 2 letters. There are only so many 2-letter words. What could it be? How do I understand 2/3 times 3 over 4 intuitively? Oh, yes. I'm taking 2/3 of 3/4 of a whole. Of is the word. Now maybe I'm not correct in this general statement, but for me personally, it makes things so much clearer. I'm taking a portion, a little fraction of something else, of a number. This number could be anything. That does not necessarily work with this. I can't say I take 2 of 5. That all doesn't work. But when it's a fraction, when it's a little portion less than a whole, then the of works perfectly. So, what can we do? I have my second number represented in a rectangle. So this is 3 over 4. So I divide it into fourths, and I'm taking 3 of them. 3/4. Showing that my original quantity is not that much. It's a little portion of rectangular pizza. Now I'm taking 2/3 of that, of what I had. Now how do I figure out what 2/3 of that is? I'm going to go sideways again. This 3 is going to determine how many sideways splits I do. Now, of course, multiplication is a more complicated concept than addition. I'm not just pulling things together or taking something away. I'm taking a portion of this. So now see it as rows. I have row 1, row 2, and row 3. 2/3 of them I need to take. So I'm going to take this one and this one, and leave that. Leave. Can I not spell, please? Because I need 2 out of 3. 2 out of the 3 rows I need. That's what this means. So my answer, I'll make a new one. I've divided this into fourths vertically, thirds horizontally. I can take 1, 2, 3, 4, 5, 6, because I'm taking what I had in these first 2 rows, leaving the third. So I have 1, 2, 3, 4, 5, 6 of them. 1, 2, 3, 4, 5, 6. So the answer is, this represents 6/12. Yes, you can simplify that? No, I don't care right now. Simplification is another thing we've seen yesterday, and I'm not going to worry about having the simplest fraction possible. I just want the answer. I can look for common factors if I want to, but that's a side thing, and I don't care about that. I'm caring about the multiplication concept. I think we should do another one. Let's do something with a mixed number on the right. So I would do it for as long as I can, separate the concepts as 2 separate concepts, when this one's bigger than 1 and when the first number is less than 1. Separate those 2. They're not the same concept. Let's take 2/5 times 1.5. We may be jumping a little bit, but we can handle it. Plus we don't have time. Right number, second number first. Or second number is what I am going to represent with my rectangle. I'm just going to make a bigger rectangle. Actually, no, I'm not. That was perfectly fine. Well, I thought I was only having 1, but I actually have 2. That one seems so much bigger than this one. They're the same. So I have 1 whole rectangle and another half. That's what I have. I'm taking 2/5 of that. 2/5 not of 2 rectangles, 2/5 of what I had. 2/5 of the shaded region. So I'm taking, let's say here, taking 2/5 of the shaded area or region or whatever. So this 5 tells me split it into 5s. Now with a little practice, you'll get 5 fairly equally spaced lines. Doesn't have to be perfect, clearly. My right rectangle there is a disaster. Doesn't matter. So I have rows 1, 2, 3, 4, 5, though you don't have to number them. I'm taking 2 out of 5 rows. Because I'm taking 2/5. So I'll take this one, thank you. And I'll leave these alone. I don't want them. I only want 2 out of 5. All right, so what do I have? Answer time. Now I need a rectangle. The answer might not just be one rectangle, but in this case we'll see if I need more. And I need to split it up into tenths by splitting it vertically halfway, horizontally 5 ways. Now it might help you to do that split everywhere, even for the full rectangles. So now let's see. I want this one, this one, this one, this one, this one, and this one, because they appeared in rows 1 and 2. The other ones aren't joining. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So my answer is 6 over 10. Six over 10. There is a method, there's a recipe for doing this that I have to follow. Not that this is the only one, but this is the one method that is fairly intuitive. I can explain it to little Timmy. Once he gets used to the method, he knows the steps involved, he can easily duplicate it. It's intuitive, it's easy, and it gets the answer every time. Now, oh, I want to erase that. What was my example here? 2/3 times 3 over 4, and the answer we said was 6 over 12. Now you do a good number of these for Timmy, and he's going to eventually notice a pattern. The general rule or pattern, let's say, not rule, rules are negative. The general pattern for how these numbers are used to create the answer is if I have A over B times C over D, it's simply A times C over B times D. Actually very good. Does that work here? Yes. That is 2 times 3, and that is 3 times 4. Yes, it can simplify sometimes. No, I don't care. Does that work here, though? The trick is I need an improper fraction, or I need a fraction. I do not, this can't be a mixed number, no mixed numbers. So for us, we'll have to rewrite that to, that's 3 over 2, and then it's 6 over 10. But of course, I'm not telling little Timmy that. He can one day discover that when the numbers make the rectangles inconvenient. When the numbers are too big. Then sure, you naturally cross over because he's going to ask, teacher, this rectangle thing is a mess. I can't do it anymore. The numbers are too big. Can you give me something else? Then there's the opportunity to see, okay, let's see if there are any patterns that we can use to skip this rectangle. Method? And, oh, look at it, it works like that. So there, we can just do that after a while. Any questions, comments? So there's more to this than just applying a formula. We have to be aware of these things because of our intended career, for most of us anyway. We need to think about this a little differently. It's not just doing it. Anyone can multiply fractions, but there's a positional issue that if I'm looking at my concept, I have a variety of positions from purely intuitive, having no understanding of the mathematical properties behind this, to no intuition and all mathematical. I'm walking between them as I need to, and depending on my audience. And I need to have the skill and knowledge to go back and forth as I need. Any questions, comments? Yes?
you got the, like, formula for the mixed numbers, or did you?
Oh, we did this yesterday, right? This is over 2, 1 times 2, because I have one whole group of 2 plus another 1.
You just convert it to.
Yeah. Or you can draw it out, whatever works. Depends on the numbers. Quotient and remainder in reverse. Any other questions? Okay, let's do a bigger one. And I want to stick to, at least for now, there may be, in the additional examples, there may be some with the right number, a mixed number, but I want to separate them because I don't want people to feel any sort of anxiety or uncertainty. So feel free to ignore those ones if you happen to come upon them. I want a fraction here, and the right number can be bigger, not the left one. Yes, we do have to be able to do that at some point, but it doesn't happen that quickly. And it's a merge of the two concepts, which messes me up a little bit. So I want to just separate the two to get us used to this idea. So, 2 1/3. On the intuitive side, I do not need to convert that to a mixed number. I don't need to worry about a general rule or formula or anything at all. My rectangles are inconsistent. That is no better. But 2 holes. And then a third of a rectangle. Only a third. It's oddly comforting to make these little rectangles. I don't know. It's nice and simple, and I'm extremely confident that I'm always going to get the answer. It's nice. I'm taking 3/4 of this. That means split it horizontally into fourths. Try and make them equal. Notice that in the third rectangle, I don't have all of those regions that I created. I only have the shaded ones. That's all I have to take from. Take 3/4, let's say from the shaded area. So I have 4 rows here, row 1, row 2, row 3, row 4. I want 3 of them. 1, 2, 3. I will take them, and I don't want that. So take a minute, see if you can finish it, and find the answer by way of a rectangle, and then write the answer. So in terms of our evaluation and quiz and things like that, it's not about doing or finding the answer. It's about using this intuitive method to explain how Timmy can find the answer. So I have to be able to explain my method, do enough so I can see that you know how to use this metric. You can always check the answer. We know how to multiply fractions. And you have a calculator as well. It's about the intuitive method. So I'm going to have my answer here that I'm going to do with the rectangles first before writing it in its number form. So I need to split them all into thirds vertically so I can count how many of these little guys I have, and they're all equal. So I have 3 vertically, 4 horizontally. Now I'm taking 3 of the 4 rows. So I want this one, this one, this one, this one, this one, this one, and this one, as well as the second row, thank you, and the third row. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 21. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I need another rectangle. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I took enough to fill a whole rectangle and partly another one. So what do I have here? 21, sorry, what am I looking at here? I have 1 whole, and 1, 2, 3, 4, 5, 6, 7, 8, 9. What is that? 12. There's my answer. Now, of course, we can check the answer because we know the general rule. I'm not telling little Timmy, but I can simply check 3 over 4. What is 2 1/3 as an improper fraction? 7 over 3. And clearly that's 21 over 12. Is that the same? Yes, it is the same. So I can check that I get the right answer, but I have to be able to explain and use the intuitive rectangle method to find the answer. So the only one that's left is division, but I think it requires a little more time, and we'll do that on Tuesday. Any questions? Comments? It takes a little bit of practice. I have to practice too, to
Really good to do this.
make sure,
Yeah,
but it's nice, yeah. Very relevant.
Yeah.
Yeah. Did everyone get their quiz?
Oh,
No. I feel I have a lot. Take your quiz. Some of the number line answers weren't explained very well. You have to